to add in solving equations that will involve complex and imaginary numbers. In each of these, the first thing I'm going to do is just solve for the variable, and that's kind of nice because they're basic equations. So I'm going to add 10 to both sides here, and I have that x squared is equal to negative 49. Now, when I go to solve for x squared, to undo an x squared, you take the square root of both sides. So right here, I'm going to take the square root of both sides. I have to remember a couple of things here. When you take the square root, this square tells you that you're going to have two answers right there. And when you take the square root of both sides, you have to include plus or minus. And I'm going to sing that to you so you won't forget it. It's always going to be the positive and the negative of those two. So here I'm looking at the square root of negative 49, which breaks down into 7i. Now I choose the positive and the negative because if I were to go back and just check this part right here and say 7i squared, that's going to be 49i squared. Well, that's 49 times negative 1, which is negative 49. Even if I were to say negative 7i squared, it's still going to be 49i squared, which is still going to be 49 times negative 1, which is negative 49. So I'm going to have to choose both of those, the positive and the negative, when you take the square root of both sides. I'm going to kind of clean this up a little bit. Okay, so on number 18, again, I'm going to solve. So I'm going to subtract 20 from both sides. So I have 2x squared is equal to negative 10, and then divide by 2, so x squared is equal to negative 5. Now to undo that squared, I'm going to take the square root of both sides. Now I have that negative 5, so I have the square root of negative 5. This breaks down into negative 1 and 5. I know the square root of negative 1, it is I. But I don't know the square root of 5, so the 5 stays underneath. So this breaks down into I square roots of 5. However, if I can squeeze this in, this is x equals plus or minus I square roots of 5. Plus or minus I square roots of 5. Don't forget your plus or minus. Okay, with a little more room on number 19, I want to solve for x, so I'm going to put all my x's to one side. Subtracting x squared from both sides, I have 4x squared minus 7 is equal to negative 8. Now add 7 to both sides, so I have 4x squared is equal to negative 1. Then we're going to divide by 4, and I have x squared is equal to negative 1/4. All right, so from here, I'm trying to get some room. So from here, I need to take the square root of both sides. Now when I look at that square root of negative 1/4, if I have the square root of negative 1/4, that's the same as the square root of negative 1 over the square root of 4. Well, I know the square root of negative 1, it's I. I know the square root of 4, that's 2. So I could write this I over 2, or I could write this as 1/2 I. Either way you write it is fine. But I can't forget that it's going to be plus or minus, and I'm going to write I over 2. It doesn't matter which way you write it. Number 20. Again, I'm going to solve for x first, so I'm going to have to subtract x squared from both sides, so I have negative x squared. So this is negative 4x squared minus 11 is equal to 25. Now I'm going to add 11 to both sides, and I have negative 4x squared is equal to 36. Still solving for x, I'm going to divide both sides by negative 4. So I have x squared is equal to negative 36 divided by 4. I cannot forget that I've got to take the square root of both sides. That didn't show it very well, but square root of both sides. So I have the square root of negative 36 over the square root of 4. When I take the square root of negative 36, that equals to negative 6. That does not equal to negative 6. It equals to 6i. over the square root of 4, which is 2. And I'm going to reduce that by 2. I'm going to reduce that by 2. 2 will go into 6 3 times, and 2 will go into 2 once. So that reduces to 3i. So here, I can write this as x equals plus or minus 3i. Now I do want to go back and show you, pick it up right here. I have x squared is equal to negative 36 divided by 4. I can reduce it right there. Well, I have x squared is equal to negative 9. And then when I take the square root of both sides, x, very simply, I can see right here is plus or minus 3i. So if you can catch it, that's nice. If you can't, you will eventually have to reduce somewhere. So it looks kind of cluttered up there, but I think if you rewrite it on your paper, it'll be pretty clear. One of the things that I had written on there that I wanted to remind you of is the additive inverse. And I'm just going to pull that in right here. Another word for additive inverse is simply opposites. It's just opposites. If I have the complex number 2 minus 6i, the additive inverse is negative 2 plus 6i. You're just changing the signs. If I have that it's negative 5 plus 7i, the additive inverse is 5 minus 7i. If I have the imaginary number negative 6i, the additive inverse is positive 6i. Whenever it asks you for the additive inverse, you just simply write the opposite, but still remember to putting that in a plus bi form. You always want to leave it in standard form. Okay, here we're just really making sure you understand what I means, and we're going to multiply. When we multiply here, we have 4 times negative 6 is negative 24. I times I is I squared. But I know that this is negative 24 times negative 1. I squared is negative 1, so my final answer is a positive 24. On number 22, I'm going to distribute the 4i. 4i times 6 is 24i. 4i times negative 2i is negative 8i squared. But 24i minus 8 times negative 1 is 24i plus 8. However, this is not in standard form, so my final answer is 8 plus 24i. It has to be written in standard form. And I remember that I squared right here is negative 1. Multiplying, you get that positive 8. On number 23, I'm going to first of all take the square root of 64. So this is 4i times 2 minus 8. And that probably was supposed to be negative 64. I'm going to change that real quick to a negative 64. Here we go. Sorry about that. The square root of negative 64. That's going to make a little more sense. So now when I distribute 4i times 2, this is going to be 8i, and then I have 4i times negative 64. Let me back up. So I have 4i times 2 minus the square root of negative 64, which is 8i. So I took the square root of negative 64. Let's just make sure everybody's clear on this. And the square root of negative 64 is 8i. Now I'm going to distribute. 4i times 2 is 8i. 4i times negative 8i is negative 32i squared. Well, this is 8i minus 32 times negative 1, which is 8i plus 32, but it has to be written in standard form, which puts the real number first and the imaginary number second. So my final answer after all those corrections is 32 plus 8i. Okay, to give us a little more room. Oh, and it took away all of my square roots. Here we go. So number 24, we have this binomial square. So the first thing I'm going to do is I'm going to write what that binomial is after I take this square root. So I have 6 minus. The square root of negative 4 is 2i. Quantity squared. Now, I can write that twice. 6 minus 2i times 6 minus 2i. And then I can FOIL it out. First, outside, inside, last. What I really like to do on this is to square double square. So if I want to square double square, I'm going to square the first, 36. Then I'm going to find the product, negative 12i, and I'm going to double it, negative 24i. Remember that product means to multiply. So when I multiply, I get negative 12i, doubled is negative 24i, and always add the square of the last. When I square this, you can't forget to square the 2. Negative 2 squared is 4i squared. But I know that I squared is negative 1. So right here, this is 4 times negative 1, which is negative 4. So here are my real numbers right here. So I have 36 minus 4. 36 minus 4, which is 32, and then bring down that negative 24i. And this is an a plus bi form. I had already combined my like terms when I doubled it in the middle. So that was square double square. I personally like that better than FOILing. And that only works if you have a binomial square. On number 25, I'm going to multiply these. Negative 7 times negative 3 is a positive 21. I times I is I squared. Again, remembering that I squared is negative 1, my final answer is negative 22 on number 25.